Welcome to the DIY Honda Garage channel. In this presentation, we will focus on the diagnostic trouble codes DTC P0976 and P0977, which pertain to the Shift Solenoid Valve B circuit in the Honda Civic models from 2016 to 2021. The DTC P0976 indicates a circuit low issue, while P0977 suggests a circuit high problem. Both codes highlight an electrical circuit malfunction rather than a mechanical failure within the continuously variable transmission, CVT. Located within the vehicle's transmission control module, TCM, the solenoid valve plays a vital role in regulating transmission fluid flow for gear shifts. When these cones are triggered, it may lead to shifting issues that can impact the driving experience, making it essential to conduct a detailed troubleshooting procedure as detailed in the following slides. The Shift Solenoid Valve B is a crucial component in the vehicle's transmission system, specifically situated within the Transmission Control Module, or TCM. Its main function is to control the flow of transmission fluid, which is vital for proper gear shifting. When the TCM sends electrical signals to the solenoid, it opens or closes to manage fluid flow, allowing smooth transitions between gears. The DTC codes P0976 and P0977 indicate issues with the electrical circuit related to this valve, either showing low or high current in the system. This means that the problem lies not with the physical operation of the transmission, but rather with the electronic signals that control it. Correctly diagnosing these issues is essential for ensuring that the transmission operates as designed and provides optimum performance. There are several potential causes for the DTC's P0976 and P0977. First and foremost is an electrical circuit issue, which is indicated by the nature of these codes, suggesting that mechanical components within the transmission are functioning normally. Poor connections between the Shift Solenoid Valve B and the TCM can lead to circuit failures, prompting these error codes. In some cases, the issue may lie directly within the TCM itself, meaning a faulty module may need to be replaced. Other causes could include shorts or opens within the wire harness that connects the solenoid to the TCM. Determining the exact cause is crucial for effectively resolving the issue. Symptoms that arise from the activation of DTC P0976 and P0977 typically manifest as shifting issues when driving. Drivers may experience hesitations, unexpected shifts, or even slippage during gear changes, greatly affecting the driving experience. The vehicle's check engine light will often illuminate as a direct result of these trouble codes being triggered. Other potential indications could include erratic transmission behavior or the feeling of being locked in gear. Recognizing these symptoms early can help prevent more significant issues and safeguard vehicle performance. It is crucial to pay attention to these signals for timely diagnostics. The first troubleshooting step involves confirming the presence of the codes P0976 or P0977 by turning the vehicle to the on mode. After this, use the Honda Diagnostic System, HDS, to clear any previously logged DTCs. This step is essential to ensure that you are working with the most current diagnostic data. Next, conduct a test drive under specified conditions. For P0976, the engine should be warmed up until the radiator fan has engaged twice, followed by driving in D mode at approximately 37 miles per hour for a minimum of 10 seconds. For P0977, shift the vehicle to P mode and let it idle for at least 10 seconds. After this test driving phase, check for any confirmed or pending DTCs with the HDS to see if the original codes reappear or if new codes have emerged. In the second step of troubleshooting, turn the vehicle to the off position. Next, disconnect the TCM 50P connector To begin inspecting the electrical connections involved, it is critical to check for continuity between test points. In this case, between TCM connector pin number 7 and the body ground. This should be conducted only when the vehicle is in the off mode. The expected resistance range should be between 10.6 to 13.5 ohms. If the reading falls within this range, it indicates that the circuit is intact, and you can move forward to verify service information or substitute the TCM for further testing. However, if the resistance is less than 10.6 ohms, there may be a short. If it exceeds 13.5 ohms, then further steps must be taken. Step 3 involves checking for a short in the SOLB wire. First, you need to disconnect the Shift Solenoid Valve B 2P connector, which will allow you to isolate the circuit for testing. With both the Shift Solenoid Valve B and TCM connectors disconnected, check for continuity between TCM connector pin number 7 and the body ground. You are looking for a direct continuity path. If continuity exists, it means that there is a short to ground, which would require repairs on the SOLB wire. If there isn't continuity, it means the wire is intact, and the issue lies with the fault in the Shift Solenoid Valve B. In this case, replacing the valve body assembly would be necessary. Step 4 focuses on identifying an open circuit in the SOL B/SHB plus line. As in the previous steps, begin by disconnecting the Shift Solenoid Valve B 2P connector to prepare for testing. You will also need to keep the TCM 50P connector disconnected. Check for continuity between test points, specifically from Shift Solenoid Valve B connector pin number 1 to TCM connector pin number 7. If continuity exists, it indicates that the SOL B/SHB plus wire is intact, and the fault lies with the Shift Solenoid Valve B, which necessitates replacing the valve body assembly. In contrast, if there is no continuity, it suggests the presence of an open circuit in the wire between the solenoid and the TCM, requiring appropriate repairs to restore functionality. After completing the necessary repairs, final verification is essential. Utilize the Honda Diagnostic system to recheck for any DTCs associated with the Shift Solenoid Valve B. This confirmation step will help ensure that the repairs have been successful and that the error codes do not reappear. Following this, it is imperative to conduct a test drive under conditions similar to those initially outlined to confirm the proper functioning of the transmission and to ensure that the shifting process is seamless. Taking these steps not only guarantees that the immediate issues have been resolved, but also helps in maintaining the long-term reliability of the vehicle's transmission system. Preventive maintenance is an integral part of ensuring that the transmission system in the Honda Civic remains healthy and functional. Regular inspections of the electrical connections associated with the TCM and Shift Solenoid Valve can help catch potential issues before they escalate into more significant failures. It's also crucial to maintain cleanliness surrounding the connectors to avoid corrosion, which can lead to shorts or bad connections. Moreover, routinely monitoring the shift performance of the vehicle, keeping an eye on smoothness, responsiveness, and any warning lights will help in quickly identifying any abnormalities. By being proactive, you can greatly enhance the longevity of your vehicle's transmission system and reduce the likelihood of facing similar DTC codes. To summarize, DTCs P0976 and P0977 are indicative of electrical issues within the Shift Solenoid Valve B circuit rather than mechanical failures. Following a systematic approach in troubleshooting allows for effective identification and resolution of the problem, whether it lies with the TCM, wiring, or the solenoid itself. After conducting repairs, it is vital to verify that the DTCs do not reappear and that the system is functioning correctly. Additionally, regular maintenance and vigilant monitoring can prevent similar issues from arising in the future. By understanding the nature of these codes and taking timely action, you can ensure that your Honda Civic continues to perform optimally on the road. Please like and subscribe to the channel. See you next time.